see why work is independent of the path. Why work is independent of path. Doesn't matter if let's say first theoretically and then we'll go numerically. Let's say you have this some certain height of building is there, and you are being asked to take this load from here to the top of building, from here to the top of building. What do you notice that no matter when let's say the object is here, and if you take it in this order, like you take this load to the top of building with the help of some ramp or some wedge, and then reaching here, somebody asks you ki what is your way of taking this load from this A to B to the top of building is completely out of a question, that why, how you have taken it there. But the question is, earlier it was here and now it is there. No matter whether you have taken it then taking first here and then pulling it by the rope, maybe just prepare you made first or construct the ramp over here and then taking the load over there, or maybe just lift it up by the helicopter first and then dropping it over here. What do we see? What do we see? That the load was here and now it is up to here. Work done is a matter to the displacement. It is always matter to the displacement, never the path chosen or the independent of path. It is always independent of path. We will see it how actually mathematically it can be proved. For example, if first of all, if you take, let's say you have a load, certain load here. This is a very interesting question. This certain load over here, and this ramp where the load is kept there, that is theta degree, at the inclination of theta degree, and we know this particular load over here is mg is, as we know, the mg is always taken with respect to the ground, and there must be some normal which is perpendicular to this this slope or this plane. So it is normal, and very opposite to this there is another component of this vector which is mg cos theta. Mg cos theta. Well, if it is theta, you can understand if this is 90 degree and this is theta, it has to be 90 minus theta. It has to be 90 minus theta. And well, again we know if this is 90 minus theta and plus some another x gives you 90, or some another theta gives you 90, this has to be theta degree. This has to be theta degree. So this theta, and we know that angle, this theta, very next to theta we have mg, next to theta is mg cos theta. That is the one of the component, and the other component is over here, which is at the perpendicular of this one. Perpendicular of this one, that is mg sin theta. Mg sin theta. And this is normal. Since the block is neither moving in any direction, so the normal and mg cos theta are equal. But if you look at this part, if I say this height is h, this height is h, then looking at this whole triangle, what is sin theta is equals to? Sin theta is equals to perpendicular upon hypotenuse. Say this part is y. Say y. So our y is h over, or better you write down this as a displacement s, this as a displacement s, and then what is our s? What is displacement? Displacement is h over hypotenuse, and that is what? Sin theta. Here we get h, displacement is nothing but h over sin theta. Now as we know, what is vector? What is the work done? Work done is equals to F dot S, and here what is our force? Force is being done in this direction. Say it is here, it is what? In this direction it is how much displacement actually we are traveling. The displacement we can see over here, it is h sin theta, h upon sin theta. And this object which is coming down this way, how much force is being applied to this one? If there is a friction force Fs, this is the force working Fs, and which is nothing but mg sin theta. Mg sin theta. See, it is F, it is your displacement, and followed by cos theta. Since both has the same direction, so we can say displacement into this, displacement is here, which is here, the same direction. The force is there, displacement is there, so the angle between them cos 0 and sin theta gone finished. So it is mgh, cos 0 is 1, so it is mgh. That is part 1, how we can say that a work is independent of path. Still, if you do it very straight, like there is a force working down the way, W is equals to force and that is the dead dot product, the scalar product of the force and the displacement. Force here is mg, and how far it has gone, just h, and still we have mg. So work done, neither matter, you just drop the body over here, you just take the body in any order, it is always independent of path. We have also another proof that the work done is always independent of path. Very soon I'll load this one in the next video.